Okay, this is classwork video 610. I'm going to have you check your work or copy down the work that you didn't do. Write down the 6 words to show that you've been listening. Please do not share these words with anybody. All right, here we go. First problem here, I'm going to have you look at this and see that this table, every time I'm going up on this column right here, that's going to be the Y column. That's going to be my rate of change. This is going up by 4, going up by 4. That means it's going to be $4 per ride. If I look over here, this graph, the rate of increase for this graph every time I go over 1 is going up 2. So this is $2 per 1 ride. And then, of course, the all-important y-intercept. This is the y-intercept. That's how much it costs to get in, $6, $4 per ride. Over here is the y-intercept. Costs $8 to get in, $2 per ride. So here we go, asking these questions. It costs $4 per ride at the state fair, and I can see that that is true. It costs $2 more to get to the county fair than the state fair. County fair, I can see it costs $8. State fair costs $6, so that would be true. And then the last one, at 1 ride, they spend the same amount. So I look at 1 on this, look up at my graph, look over, 10. Look at 1 on here, I got 10. So that is another true statement. All right, moving on. This one, they want the equation of the line. Remember, for an equation of a line, you need the slope number, the number in front of x, and you need that y-intercept. To find the slope, that number in front of x, I'm going to connect 2 dots on this line and count my boxes. Looks like I could go either down 3 right away, right 2, and then hopefully you're seeing that slope is rise over run, -3 over 2. That is my rise over run. That's the number that's going to go right there in front of x. And then my y-intercept is this number right here where it's touching the y-axis, that 5, which could be written, of course, as 0.5. Just like over here, this could be written 0.8. First word is blue. Blue. All right, so here we go. With this, having the y-intercept being 5, slope being -3 over 2, I'm going to write that equation. The y stays there, the equal stays there, but where that slope used to be, -3 halves over 2 down 3. Make sure to put the x there, and then you have your y-intercept, which is that 5. So y equals -3 halves x plus 5. Please don't forget the x. All right, moving on. Finding the slope. So for this, I can see that this is going down 3. And then to the right, 1, 2, 3, 4, 5, 6. Right 6. So again, if I put that slope together between A and C there, that slope put together gives me -3 over 6. If I want to find the slope from A all the way to H, I'm going to look at going down, looks like 1, 2, 3, 4, going down 6. And then going right, looks like I'm going right 12. So if I put those numbers together, that would be -6 over 12. And then how do they compare? They are equivalent. Make sure you are able to write that in a sentence. They're equivalent. They have the same value. Even though they look different, one with 3, one with 6s, they have the same value. They're both -0.5. Both of them have the same value. They're equivalent. Different numbers, but the same real value or answer. All right, next. This one says a pair of solutions or a system. Remember, a system means you have either two parallel lines that never touch, or you have a system where two lines meet in one place, or you have two lines and they overlap. So remember, if they never touch parallel, no solutions. If they touch in one place, one solution. If they overlap, many or infinite solutions. This says, what would a pair of lines look with no solution? Of course, that would be the parallel lines. Right there. All right, moving on. Number 5, tough one. Is solve a system. One, I'm going to have you do it graphically. One, algebraically. Let's do the algebra one first. So this equation, that's really 1x right there. So the opposite is to subtract 1x on both sides. That will cancel this away. This y being positive, I could just leave it alone. Bring down the negative 1 with the x, the negative with the x. That 1 right there originally was positive 1. Leave it positive 1. That's my first line. So start at 1 on the y-axis. This is the y-axis, x-axis. Start at 1, and this has me go over 1, down 1. That number in front of x for this, made as a fraction, tells me every time I go right 1 from that starting dot, down 1, right 1, down 1, right 1, down 1, right 1, down 1. Stair step the opposite way. Try your best. Draw a nice straight line through those points. Use a straight edge if you need it. All right, next one, tougher one, because I have a negative right here in front of y. Can't have that negative there. I need to get rid of that eventually. But this 2x being positive, I'm going to subtract 2x on both sides. I need to make sure I remember to bring down that negative with the y. That negative 2x, I write, and then that plus 5, that's positive 5. Now this last step is tricky because that negative is negative 1 times y. So I'm going to do the opposite, which is dividing by negative 1. I got to make sure I come over here and divide both those by negative 1. You can see how tricky that is. That makes this y positive now. It switches that negative 2x to positive 2x. Switches that 5 positive to negative 5. Second word is fish. Fish. Now if I graph that, negative 5 on my y-axis, right 1, up 2. That number in front of x being 2 made into a fraction. Right 1, up 2. Right 1, up 2. Right 1, up 2. Draw a line through those. And then you could see that they meet right here, one solution. And that one solution for x and y looks like 2, negative 1. 2 for x, negative 1 for y. That is the solution point. All right, next, solving this algebraically. I'm going to have you take this bottom row and times it all by negative 1. I'm going to have you distribute that all the way through. And then please take the step to rewrite them. So here I go. That top one rewritten as the exact same because I didn't touch it. That bottom row, though, becomes negative 5x, negative 2y, which you want to slash off that positive 2y above it. And then negative 10 all the way down becomes positive 10. Careful. Now if I plus these or combine these, opposite y's go away. 3x minus 5x gives me negative 2x. 6 plus 10 gives me 16. Now right there, opposite timesing by negative 2, dividing by negative 2. That will make these go away. Gives me x equals negative 8. That is half of my answer. I need to find the other half of my answer by plugging that in and doing the algebra. So again, that's only half of my answer. If I take that 8 and I plug it into one of these x's, I'll be able to solve algebraically for y. So here I go. Where that x used to be, everything else the same. I plug in -8. I'm solving for y. Before I do any algebra, times 3 times -8 gives me -24. And then right there, now I'm doing algebra. The opposite of -24, add 24. And then I'm going to divide by 2. Bring that 2y down. Make sure you add 6 and 24. That gives me 30. And then right there, last step, opposite timesing by 2, dividing. And that gives me y equals 15. Make sure you put that number right here. I wanted to check it. I could do 3 times 8 gives me -24. 2 times 15 gives me 30. Does that give me 6? That should work. If I plug in the other one, 5. 5 times -8 gives me -40. 2 times 15 gives me 30. Does that equal to -10? And that is true. All right, let's move on. Next problem just says, look at this and see what applies to this. I can see that this is a one solution. They're meeting in one place, and the one place they're meeting is that coordinate right there. It looks like going over 2 up 3. So that would be, of course, C right here. Then we want you to pick one of the bad ones and explain why. And I would say maybe either A or B, easy ones. One with a infinite number of solutions. You could say B is wrong. It says, explain why it's not true. B is not true because infinite solutions would be overlapping lines or same lines. Then you could say A is wrong because A, no solution would be parallel lines. A is not true because no solution would be parallel lines. So anything like that. You could talk about how the last one, D, is not right because these are the y and x intercepts, if we want to talk about that, where the line is touching the x-axis or the y-axis. All right, next, number 8. It says, which is the following is not a function? You're looking for the breaking of the rule. For input, there can only be one output. For every input, only one output. For these, if I could identify a number with 2 arrows shooting out of it, that's like a coordinate with being 5, 4, and then another one being 5, 6. You can't have the same x coordinate spit out 2 different y coordinates. Can't have that. That's an input spitting out 2 different outputs. That would be like me taking an equation like this and one day plugging in 3 for x and doing the math. And then the next day, for some reason, doing that same math and getting a different number. Can't have that. That is impossible. That wouldn't work. Every time you plug in 3 into that same equation, you would get 10. If you plug it in and got a different number, that's breaking the function rule. Can't have that. All right, let's move on. Next word is red. Red. All right, this one, comparing. If I go bus 1, that is 40 miles for every 1 hour. If I look at bus 2 here on this graph, looks like every time I go over 1, I go up 1, 2, 3. So that would be 30. So over 1 here, up 30. That is 30 miles for every 1 hour. Which bus is moving faster? Number 1 for this situation. How do you know? I know because it has a greater rate. One is 40 miles per hour, one is 30. You could say, I know bus number 1 will be 10 miles further than bus 2 in an hour. So if they were both driving an hour, bus number 1 would be 10 miles further down the road than bus number 2. I know because bus number 1 has a greater rate of change. All those things you can say. All right, this one, comparing slopes and y-intercepts. This one, keep them going how I've been doing it, kinda. Going down 2, going right 3. That is my slope. If I do that, that gives me -2 over 3. Let me just backtrack, make sure that is correct. Yes, that's over 1 down 2. That is my slope. My y-intercept is that 5. So if I look at that, this has a value. If I divide -2 on my calculator first, divided by 3 on my calculator, it should spit out -0.6. This has a y-intercept of 5, written as a coordinate 0, 5. All right, my table. This rate of change here, because x and y are on my table, this is going up by 1s, it says. So I could just focus on my y numbers here, which look like they're going down by 1. So if I put that together for this one slope, that's -1 over 1, or of course -1. This one has a y-intercept of 0, 7. That's how I find the y-intercept in a table. Look for when x is 0, whatever that y number is. And then compare. Looks like the graph has a smaller slope. The table has a greater slope. The graph has a bigger y-intercept. Oh, nope, it doesn't. So it looks like this table has both. So I could say the table has a greater rate of change. It's -1. That's going faster down than -0.6, which is really -0.6 over 1, really. Every time I go over 1, go down 0.6. This one, every time I go over 1, I go down a whole 1. But this says the table has a greater rate of change and a bigger y-intercept. All right, let's keep going. Number 10, this one wants you to solve it for y and compare. So if I take that, let's write it right here. I'm going to first add this 3x. That will cancel this away. Bring down this 2y. I got 3x plus 10 Right there, divide everything by 2 because the opposite of timing by 2 was dividing by 2. And I can see for this one, I got y equals 3 halves x plus 5. This one has a slope of 3 over 2. If I divided that in my calculator, that's a value of 1.5. This one has a y-intercept of 5. My graph, here I go. The graph looks like my slope is over 1, up 1. So that's a value of 1. This one has a y-intercept of 1 right there, or 0, 1 on my graph. So I can see, looks like the equation has the bigger rate of change and the bigger y-intercept. So for this situation, the equation has a greater rate of change. .5 is greater than 1 and has a bigger y-intercept. Well, of course, you'd say a greater y-intercept, but we'll say bigger y-intercept. Greater, talk about greater rate of change, bigger y-intercept. All right, move on. Here we go. Number 12. For this one, looks like I already circled it for you. So hopefully you got that one right. All right, moving on. Number 13, and back to this one real quick. Just make sure you know these equations that we've been doing with a slope number and a y-intercept always will end up being a straight line, either a positive line or one that's going downhill, a negative slope line, but they'll always be straight. All right, number 13, they want you to see that this 5, my rate of change here, because this is, again is x and y. X is going up by 1, this y's are going up by 5. If I put that into slope form, that's 5 over 5. Be able to backtrack. If I wanted you to find the y-intercept in this situation, subtract, go backwards, down by 1 here, down by 5 over here. So my y-intercept, taking this 11 minus 5, is 6. Be able to write an equation for this. This is y equals 5x plus 6. Know that that number 5 in front of x can be written as a slope 5 over 1. But know that that y number is the dollars and the x number is hours. So that $5, every time I'm adding 5, that's really $5 an hour more. Each hour I'm adding 5. Each hour I'm adding 5. So you can see that 111 kind of misleading because some people think that's $11 per 1 hour. But this, you can see at 0, it was $6 already, just adding 5 each time. So that $5 per hour. All right, next with this one, looking at increasing speed for 10 seconds. That would be 2 boxes. Looks like this first one here going up by 10 seconds increasing, slowing down for another 2 boxes, 10 seconds. Looks like staying the same speed for 30 seconds. 1, 2, 3, 4, 5, 10, 15, 20, 25, 30. Looks like that's 30 seconds. And then slowing down for 10 seconds. Looks like that one right away is good. This one is no good because it looks like it's slowing down here. Oh, that's right. So increasing good, decreasing good. Let's see. 5, 10, 15, 20. Ooh, this one's no good because it's going the same speed there at 25. That doesn't match that. So that's why this one's no good. And this last one's no good because right here I could see this stretch is decreasing for 15 seconds. Doesn't match that. So that's why that one's no good. All right, let's move on. Next word is dog. dog. All right, this one, it wants you to see, let's see, 15-second mark going faster than the 60-second mark. You know, that's false. The cheetah increased speed for a total of 20 seconds. Let's see, going uphill right here. 5, 10, 15, 20, 25, 30. We was going up 30, so that's no good. All right, the cheetah's speed remained the same for 20 seconds. 5, 10, 15, 20, 25 seconds. It was going the same speed, so that's no good. The cheetah's speed spent longer increasing than decreasing. Looks like it spent 5, 10, 15, 20, 25, 30 seconds speeding up versus right here slowing down 10 seconds. So that one is the true statement. All right, moving on. This one, the way it looks, I can see that it is not linear. It is not anything I could see to know if it's going up or down. Let me try to find this problem here. So read this. All right, it says they're positive, but I can't see anything. If it was positive, it would be going uphill like this. It's non-linear. Yep, that's the one. Non-linear means that those data points are so spread out, they do not form a line. If I wanted it to be positive, they would have been uphill. If I wanted it to be negative, they would have been going downhill like that, where I could see a line. But again, there's nothing. They're spread out. All right, next problem. 16 for this one. If I could find it. All right, 16 says, which is true? This pattern shows linear, nonlinear, positive association. So this one kind of has two answers. You probably won't be like that on the test, but this shows linear. It is a straight line. So that would apply. Nonlinear doesn't apply. Positive association, that applies too because they're going uphill. So that one has two answers for this. I'm not sure on the test that will be the case, but for this, linear, yes, they are a straight line. Positive uphill, yes. All right, next problem there. This one says, which one shows the negative correlation? Negative going downhill. That would be this one right here. This one is positive going uphill. This one is so scattered, we call this non-linear. Can't see anything. All right, moving on. Number 19, and the next word is black. 19 says, which line matches that data better? And I can see the line going right through the middle for this set is line C. Line A, too much of an angle. Line B is too high. And leads into this next one here. Looking at that graph, it says which is true or false. It says the line should be adjusted higher to be a more accurate fit. That would be true. Next says the line should be adjusted higher to be a more accurate fit. Looks like I got a double there. That also would be true. Not sure why I did a double. That's it. The line should be adjusted lower. That would be false. Don't want to adjust that line any lower. And then the line shown as a best fit. That would be false. 2. All right, check those words. Last word is cat. Check your work. Study that. See you on Monday. Good luck.